Hello everyone. So today we are going to discuss the set 6 of the problem set of TCS NQT. So without further ado, let's begin. So particulate matters are the biggest contributors to daily pollution. Main reason behind the increase in concentration of PMs include vehicle emissions. By applying odd even concept for all vehicles, the vehicles with the odd last digit will be allowed on roads on odd dates. Those with the even last digit will be on even days. You're given an array and you're also given a date. Your task is to calculate the total fine collected by traffic police department from the vehicles violating the rules. So basically you have been given an array, you've been given a date and also a fine value. You have to calculate how much is the total fine value if only even registration numbers are allowed on even date. So for example, in this test case, the fines will be collected from 5, 3 and 7 because they're odd running on an even date. So the total fine will be 200 times 3 because there are 3 instances of such members. So let's quickly move to the code because there's nothing much more to explain in this. Let's take the input, take up our array I plus plus C in A of I, and then uh, we can just do all the things inside this loop only. So basically, if the parity of this, also we have to take up the input of date. So yeah, we have to take the input of date. So yeah, we can just pick up this input first. After that we have to pick the input of date. Let's pick up the date, also the fine. Let's input the fine. Then again, for and I is 0, I is less than n, I plus plus. Then we'll check if the parity of a of I is same as the parity of date. Means if if it's odd then it will get 1, and if the date is all odd as well it will give 1. So basically what this does is it checks if both of them are odd or even. If both of them are odd or both of them are even, it will return true, else it will return false. So our task is to get that our task is to find if these two numbers have opposite parities, like one is odd and one is even. So we'll just put a not equal to here. It will simulate that if the parities of a of I and d are different, because we will find only those vehicles which have a different parity. So it's also take up a some integer, and let's just add the x value, that's the fine. Then let's just print s. So let's just try to run it with our example. 5237, 5237, 12 and 200. Answer should be 600 because there are three different vehicles. And here we go, answer is 600. You can also test another test case. 52168, 2168, 25168, sorry, 25168, 3 and 300. 300, its solution should be the number of evens times 300, means the answer should be 900 as is expected. Our answer is 900. So yeah, pretty straightforward question, nothing really much to talk about this. So let's move on to the next problem. A zoo consists of two types of animals with different number of legs. Zoo management wants to find out how many types of animals are there with each category. N represents the total number of animals, L represents the total number of legs. Find out the numbers of animals of each category. So if you look closely, this problem resembles, it is clearly the same as the one that has been asked in a previous year problem that talked about vehicles. Like it, I guess that problem is the first problem of this problem set. So basically in these type of problems you have to form mathematical equations and solve them. So basically you are given the total number of animals and the number of legs. So let's discuss how it can be done. So First of all, let's assume that okay, we don't have to assume. They are given that there are only two types of animal: two legs and four legs. So let's just assume that two legged animals are x and four legged animals are y. So x plus y is given, that's n. Also, we are given the number of legs. For two legged animals, there will be 2x legs, and for four legged animals, there will be 4y legs, and 2x plus 4y is L. We can just reduce this equation by taking 2 common. I'm just skipping that step because we have already done this problem before. This is equation 1, x plus y equals n is equation 2. Just subtract these, we get 0, y is L over 2 minus n. Similarly, we can just substitute this value y here. We can get x as uh, n minus y, which is basically n minus L over 2 plus n. uh, just redistributing the signs, we can get 2n minus L over 2. So yeah, this is the problem, and the only difference in this problem is we are given the constraints. In the previous problem we had to output -1, but in this problem the constraints are already given, so we can just plug in the values of x and y that we have obtained. So let's just take up the input: intel, cnel, and x, as we found out in our solution, is 2n minus L over 2. Let's just check upon it. 2 into n minus L over 2. Also, we have been given this constant that L mod 2 is 0, means L is divisible by 2, so this must not be a problem. Then y is basically n minus L over 2. Y is n minus L over 2. Our task is to print them in this fashion. Like the first line should be two-legged animals and the next line should be four-legged. So let's just print it in this fashion. TL. Let's see the input format again. There's no spaces, I guess. Yeah, there are no spaces. Then TL equals X, and in the next line we'll be printing four-legged equals four-legged animals are Y. And yeah, this sums up the problem. Let's just take up some test cases. N is 200 and L is 540. 200 and 540. Let's just see if everything is working all right. Let me check if there's a problem. I guess we have taken, yeah, y is L over 2 minus n. So let's just update it. Yeah. So yeah, let's just run this problem. Answer should be 130 and 70. Here we go. Answer is matching exactly, that is mentioned here. So yeah, the pretty basic problem. We have solved this particular problem in P1 as well, as you can see. So yeah, interesting problems. So all the best.